Hello, everyone. Welcome, everyone, to Scaling the Sound, Fleet Management at Spotify. Or, a more interesting title, walking you all through Spotify's journey towards what we refer to as a fleet-first mindset. Over the course of my talk, I'll explain what that is exactly, as well as why it was important to define and communicate for us. But first, a little about me. My name is Daynesh Mangal. I'm an engineering manager at Spotify, managing two of our squads, Starfleet, the owners of a product called FleetShift, and Toast Infra, the owners of a product called Soundcheck. I was born and raised in NYC. I've spent my entire career working with engineers, joining Spotify about 3 years ago, maybe 3 years and a day ago. I'm part dad, part engineer, part leader, and forever a tinkerer. This is me. Gemini has given me hair, which is, I can't complain about. So, what do I have in store for you today? We'll start looking at some important metrics to get an idea of the magnitude of the problem we aim to solve with fleet management. We'll then dive into what life was like before we solved it. We'll go through the journey itself in solving some of these problems, rounding out our talk to what life is like today at Spotify managing our fleet of production software. And finally, closing with some of the exciting things we have to look forward to. A little background. Spotify has grown incredibly from its infancy many years ago to now having an impressive 675 million users today, containing a library of more than 100 million tracks, and we're supported in more than 180 markets worldwide. Just as impressively, our technology organization currently has about more than 2,700 engineers. On average, we perform more than 4,100 production deployments per day. And if that wasn't interesting enough, in just 2024 alone, we've had more than 652,000 automated PRs to Spotify repositories. So, why present these numbers? I want to present two scenarios Spotify has encountered over the years of running a platform organization. And I bring these up as I wonder how familiar these scenarios are for other companies, for all of you out here. Scenario number one, updating the Java runtime. We need to update the runtime of all of our company's backend services. That's right. Not our team's backend services or a specific individual team, but our entire organization's services. How long does something like this take us? Well, before pre-fleet management, we generally managed and measured software migrations like this as spanning many months. Another scenario. We need to update everyone's version of their favorite service framework up to the latest version that's available. How long does it take to do something like this? Well, typically for Spotify, it's taken us 200 days to update Apollo, which is our internal service framework. I want to stress that this type of work is really important to get done. But it's also important to not underestimate the effort to do that for an entire organization. Maintaining technology is not free. I realize I'm speaking to the choir. So, let's go back in time for a second. When Spotify was a incy-wincy baby, they had this model, the Spotify model, around 2010, 2011, where each team was like their little startup. We call them squads. They strive to be autonomous, and the idea is that you'd have the right people to do back-end, front-end, data, whatever is needed to ship features you're responsible for, and you also made your own decisions, whatever was necessary to achieve your mission at the time. It allowed you to really move very fast as a startup. Everyone doing their thing. It was great. Everyone loved it. Over time, we found more and more success. We acquired more users. This lent itself to receiving more funding, which in turn allowed us to hire more. We built more teams, and they built more software. And in time, we invested in helping our new hires get up and running quickly, building new software in a streamlined manner. But wait, if more and more software is built, what about the old software? Who keeps all of that software up to date? By 2021, we had a bigger problem on our hand. On the surface, looking at this graphic, it looks pretty impressive, and the truth is, it is. But the hidden insight into this graphic is that who maintains all of these new software components? And the burden lies on the squads themselves. So, what is maintenance work anyway? What is this work that has compounded over time? Some examples that come to mind include migrating Java 8 to Java 11, Java 11 to Java 17, migrating one Ubuntu image to another, deprecating some end-of-life homegrown technology to some off-the-shelf managed solution. I like this quote. Carl Lindstrom had this in an internal technology talk years ago when he was a senior engineer, and it stuck with me when I first heard it. Maintenance is that thing that gets between me and what I want to do. We in our platform organization like to refer to this type of work as engineering toil. Every engineer is familiar with it. It's necessary work, but not the most fun. So to summarize the problem we have valuable software that drives our business, and it needs to be maintained and oftentimes extended. We need to ensure that our engineers move fast, not just initially, but over time. And what are our challenges? Engineering toil takes time. It's also boring and repetitive. It leaves less time to build rich product features, and in time, it can eat into our flow, our satisfaction. And this is exactly the type of work you want to automate. So what was stopping us? It was a combination of Spotify's valuing of squad autonomy, simultaneously scaling our organization with minimal standards at the time in place. And this ultimately led to a rather fragmented technology ecosystem. And this is where our journey begins. So, to solve this fragmentation problem, we needed to invert the problem. What we needed was to defragment Spotify. This was such an important problem to solve for us that we defined a company objective for it, and everyone pitched in to help prioritize it. We developed a new mantra. We take the pain away, so that our users, those whose software components will benefit from being defragmented, don't have to perform this toil as we promise to do it for them. What sort of strategy did we need to follow? That is to defragment Spotify and really allow automation to take this engineering toil away. First, we needed to define what the state of tech standardization will look like. This is what we would define as golden tech. Next is the even harder part, helping Spotify adopt this golden set of technologies. If we accomplish this, we'll then finally get to the promise of what we really want here, which is, no, not that. The promise really is to leverage automation to remove that toil from all engineering teams. We tell our developers that instead of you always staying on top of which libraries your software uses or having to patch security vulnerabilities, we'll do that for you, and you won't even notice that we're doing these things. Now, what is Golden Tech? First and foremost, it's a set of technology standards for everyone to build on. By defining these standards for all, we take advantage of positive effects of consistency. Easier development and maintenance, reduced errors, faster development cycles, improved code quality. This screenshot you see here is the most up-to-date definitions of our golden technologies at Spotify. Shown in Backstage, a developer portal, a specific plugin or page we call our Tech Radar. Now, adopting golden technology involved a multifaceted approach. We invested in standardizing how we build new software, which I alluded to earlier, our golden path, a self-paced guidebook for how to build and deploy different types of software in Spotify. And we have software templates for creating various types of software as well, whether it's a backend service, a Shio-based streaming pipeline, an ML Cube flow pipeline, a website, you name it. But we also needed to double down on other areas that support this vision as well. Areas in our stack that must transform if we are to achieve this area of automating maintenance work and doing so frequently. Areas such as defining all of our cloud resources declaratively. When we need to make changes to cloud resources, how they're provisioned, configured, etc., we don't want to do that through bespoke software, but ideally simply updating some set of YAML files. And it turns out it's much easier to automate changes to simple code like YAML files than it is to more complex code that's distributed across various types of various directory structures in a repo. And you can see here an example, a screenshot of what that looks like. Another area we needed to support was reimagining our CI/CD platform. I mean, if the future was going to look like hundreds to thousands of migrations a year, our CI/CD platform will need to support many, many builds and deployments, far more than what we had at the time. So you can imagine now, once a squad adopts Golden Tech, your squad services would reach what we termed a golden state. And this is where we want software to eventually get to. The incentive is that the closer you get to golden state, the more maintenance updates come for free for you. Now, if we want to make sure all of Spotify is adopting this golden tech that we've defined here, how do we measure our progress towards this defragmentation end goal? We use Soundcheck. Soundcheck is a tool, our tool, that helps you measure quality, reliability, and alignment of your software ecosystem. It incentivizes teams to reach levels of certification by passing checks for your software. And we can even zoom out at a higher level and see how well a whole department is doing with their overall tech health and certification levels. All of these tools I've shared thus far in our journey are built and designed plugins in Backstage, our single pane of glass for all of our infrastructure at Spotify, whether it's Tech Radar, software templates, Soundcheck, CI, and CD plugins. Backstage brings all platform engineering solutions together for us, encouraging interoperability between these capabilities, which unlocks this compound value for our organization. So now that we were on our way to standardizing our tech ecosystem and defragmenting the landscape, we needed to invest in building this promise of automation. Here is where we invented FleetShift, a tool for performing large-scale code changes across the fleet. What you see here is a screenshot of an automated pull request for a services repository for updating their service to a new version of Spotify's BOM, a Maven POM file that helps manage the versions of Spotify's most important dependencies. Once your service has attained a certain golden state, certification level, you can expect PRs like these to keep you up to date. And this is a really high level, I don't want to say a systems diagram, a functional diagram. How FleetShift works is that, let's say you want to change a key value pair in all Java services build files, which turns out to be, let's say, YAML file, but it doesn't have to be YAML files. You would define a set of instructions, who you'd like to receive these changes, which repos, for instance, when you'd like this large-scale change to run. Some parameters you'd set to customize its behavior. Some, like, should the PRs be automatically merged? Should PRs be created? Or just let branches be created, for instance. You also write the code, what we call a shift, that will perform the change in whatever language you choose. But you build it as a Docker container. FleetShift then executes your shift as a Kubernetes job, cloning the relevant repos, executing your shift's transformations, and pushes the changes to the target repo's branch. This is all while FleetShift is tracking the shift progress, listening for errors or success, and if applicable, a PR will finally be created and potentially be auto-merged for you. But if ever there are any CI failures, the PR will never really get auto-merged. And this is a very high-level diagram I mentioned. And under the hood, you can expect there to be a suite of different software components that drive all of the functionality that supports this. But believe it or not, one of the hardest challenges that we needed to overcome was not actually building the software, but helping change the culture that was needed to support fleet management itself, or what we called adopting a fleet-first mindset. Owners of software had to change their expectations in that other systems would be making their changes to their own software and deploying those changes automatically without them being in the loop. That's initially very scary. It requires a building of trust and confidence over time. And for this to truly work, there needs to be strong engineering practices, in particular, test automation. If an automated update breaks your component, you'll need to put a test on it. This is what we internally refer to as the Beyoncé rule. There's also some interesting consequences if your software is, quote unquote, not managed. It will quickly fall behind because you'll have to spend manual effort and a certain amount of your team's capacity keeping it up to date. Another change that manifested itself in the past, there tended to be this mindset where we would perform the work to add some new capability in a platform, but would tend to stop short, not intentionally, but stop short in assuring the adoption of that said capability. With a fleet-first mindset, our platform owners now had to own the adoption because they have the tool to help them support that. Adopting their new capability by creating a new shift to roll out this capability to the entire fleet. And the impact of anything our platform teams now expanded at a massive scale. So FleetShift today. Remember our slider that showed how long it would typically take to upgrade everyone's version of their service framework? With our efforts behind fleet management, we went from 200 days to less than 7 days to update every production services version of the Apollo library, our internally developed service framework. And today, we've had more than 1.8 million contributions to the fleet authored by FleetShift alone. And currently at a ratio of 3 to 1, and climbing between bot contributions and human contributions. And today's shifts range in complexity too, from simple string replace changes and version bumps to shifts that involve more complex migrations that can leverage multiple AST transformations affecting many files across repositories. And in 2021, we, just like many organizations out there, became aware of a critical security vulnerability with a foundational logging library we use under the hood for our Java services. What would have absolutely taken an exorbitant amount of time to update the log4j version being used, or versions being used, with Fleet Shift, it took less than 11 hours to update 80% of the fleet. Lastly, I would not be here speaking about such an amazing platform and the incredible journey that Spotify has gone through had it not been for the squad that owns and operates fleet management. This is Starfleet, my squad. The future. So we have some really exciting things to look forward to, and it builds on top of the successes of fleet management within Spotify. We've been investing in cleaning up our production environment, undeploying various types of software, various types of experimental and deprecated software specifically. And why that's important? Well, in addition to it amounting to a tremendous amount of cost savings on our cloud bill, it turns out that we spend a decent amount of time managing shifts that unnecessarily target orphan repos, or repos that are no longer of use, as well as countless hours spent by our security squads trying to fix vulnerabilities on repos that are no longer used. We have also recently been reimagining ways to reduce toil even further for all of Spotify, and exploring other ways to make automation better and more helpful for our engineers. For instance, exploring going from a polyrepo world to a monorepo world. And more R&D and LLMs, and how we can leverage those fast-paced technologies to help our engineers even further. And if you like this talk, be sure to join my colleague Stefan Sarne, our senior staff engineer, dive into further fleet management details on Thursday afternoon. And finally, be sure to stop by our backstage booth in the Capitol Hall area and say hi. That's it. Thank you, everyone.